All right. So Ayush had raised this question last time that he was having a hard time visualizing the point view of a three-dimensional line with respect to this, what I would call virtual box, right? So yesterday, even I was having a hard time, and I went back. I was like, how would I do that? But then I could figure a way out, and maybe I'll share that with you. Okay, so hopefully things will become clear. In particular, with regard to the distance that we were taking to get the point view. So this figure is clear to you, right? Is it? Is it? Yes or no? Perfectly clear? To whom is this figure not clear? Wonderful. So projection in the horizontal plane, on the horizontal plane, projection on the vertical plane, on the vertical plane. These distances are essentially these distances, okay? So pretty much there, right? And if you figure the intersection of the green and the blue line here and the green and the blue line here, you have two vertices of a three-dimensional line which is enclosed within a virtual box, right? Draw this plane that would contain this projection as well as this three-dimensional line. Okay. Now this step is critical. Project this plane forward in a manner that you are actually getting this guy along with this plane and this guy, which is the image of this, along with this plane. Okay. Get these two hinge lines. Okay, and when you are drawing this hinge line with respect to the horizontal plane, so this hinge line would be parallel over here. Okay, so you'd be essentially flipping that plane over in such a way that all these three planes lie on the same plane. That's what the basic idea is. Okay, now follow this carefully. This is fine. I've shifted this entire figure over there. Okay. Now yesterday, two of you came and I asked how you would be able to locate the plane that would contain the point view of this three-dimensional line, and somebody was looking way up there like that. All right, so let me try to get that plane on this picture. Okay, so the idea is that we are going to be looking on this line, okay, like so. Okay, so perpendicular possibly to this plane. So I draw two planes, or rather I draw this plane parallel to this plane here parallel to this, okay, and the back plane which is parallel to this plane which is containing the three-dimensional line. Fine so far? With me so far? Okay. It's a little messy, so I would take away certain information that I don't need at this time. Okay. So what I'm left with is just the horizontal projection over here, the vertical projection over here, and the respective planes. Okay. All right. Now this view is probably not very comfortable for me to work with. Okay. So what I'll do is I'll enclose this entire thingy within a cube and rotate the cube a little. Are you with me, or you are? So what I'll do is I'll essentially transfer all this information onto a cube and rotate the cube. So what I'll do is I'll transfer this information, this distance, this distance, this distance, and this distance. Okay? Just carefully observe. Okay, one more time. This edge is now going to be one of the edges of the cube. Okay, I'm going to be measuring the red distances, and I'm going to be placing this blue line on the horizontal surface. I'm going to be measuring these green distances onto the vertical plane, and then I'm going to be having this red line, okay, at the end, at the two ends of these green lines. Okay, watch carefully. Okay, now it becomes a little easier for me to visualize the point view of this three-dimensional line. Okay? All right. Of course, for the point view, I'll have to be looking at this three-dimensional line from here. So I'll have to draw a plane that would be or I have to sketch a plane in such a manner that this guy over here is perpendicular to it, right? Perhaps this is what my plane is. It will be an inclined plane. Okay? It won't be parallel to the vertical, nor will it be parallel to horizontal. It will be an inclined plane. Okay? And let me assume that I'm going to be having a hinge line here for now that passes through one of the vertices of this red line. Okay? So the idea is for me to flip this plane about this hinge line like this. Okay? Let me try to capture the point view here. Follow this very carefully. But before I do that, I'll ask this question to you. Is this the actual three-dimensional line? It's just the image of that, right? Okay, so I should be considering the actual three-dimensional line. Okay, look at that figure over there. The black line is something that I'm interested in, not the red line. Okay, now for that, I'm going to be using this distance. I'm going to be using this distance, and this is where my black line is. Okay, so this plane, black dashed plane, is going to be capturing the point view where? Over here. Isn't it? Isn't it? Right? Not there, but here. Now your question was, how do I correlate these distances with this one? Now it's clear. Is it? Right? Now that plane need not be passing through this vertex of the red line. It can be anywhere so long as it's parallel to this plane. Okay? So I can move this plane perpendicular to this line and along this line. Yeah? Once again, it doesn't really matter where the location of that plane is. Now what I would do is I would rotate that plane about that black hinge line. Like so. And when I do that, this guy would be coming where? Here. Clear? Now is it okay for you to correlate this distance with this distance? Clear? Yeah? Anybody else? You're right. For your consolation, this is not good tea. It doesn't taste very good. Anyhow. Okay, so having understood this, let me move forward. So visualization is only one aspect of it. Okay, so with practice, the more you practice, the more it becomes easier for you to follow this mechanically. Okay? Anyhow, parallel lines. Given the projections of a three-dimensional line CD, okay, in the vertical and horizontal plane, and you also have the projections of a point A, okay, the vertical plane projection here, the horizontal plane projection over here, I'm expected to draw a line that passes through A, which is parallel to CD. Okay, how do I do this? How do I do this? I'll have to visualize this line. Point view or true length? I'll have to figure out a plane in which this line is in true length. Yeah? Hinge line. Okay? This view is going to be, I'm not sure which one is going to be common. All right, so this view is going to be common because I'm using another hinge line. I'm going to be making an auxiliary plane, draw projections perpendicular to this hinge line, measure what distances, measure this distance, transfer it over there, measure that distance, transfer it over there, and this is my line C1, D1 in auxiliary plane 1. Remember, I can use as many auxiliary planes as I can or as I would want. So this is the first auxiliary plane. That's the reason why I'm using the subscript C1, D1. Okay, and this would be in true length. Great. So it's really nice to get the feedback from you. So this would be in true length. Okay, so now that I have located the plane, I have to do the same exercise to get the corresponding projection of A on that plane. How do I do that? I'll draw a projector perpendicular to this hinge line. From that point, I'll measure this distance, transfer it over there. That is where my point A1 is. Okay? And then I know that this line is in true length, so I can draw a line passing through A1 which is parallel to C1, D1 of any length. Okay? Of any length. Right? And this is, let's say, point B1. I take B1 back. I'm going to be using the same rules now. I'm going to be taking B1 back. Where do I locate that B1 over there? Now, would this be in true length? A1, B1. Okay. So if one of if these lines are parallel and if one of the lines is in true length, the other one has to be in true length. Okay. Now, how do I locate B1 in the horizontal plane over there? How do I do that? I don't know the distances right now. I don't know the distance. But what I know is if this is in true length, its corresponding projection in the other view has to be parallel to the hinge line. It has to be parallel to the hinge line. Okay? Which is what I'm going to be using. So I'm going to be ensuring that this guy is in true length. I'm going to go up and I'm going to draw a line segment which is parallel to this hinge line. Okay, once I get that, now I can use the distances. Now if I project this BH downward, okay, I can measure this distance and transfer it back over here down. And there is the projection of AB in the frontal plane, on the vertical plane. Right? Right? Okay, so I have not mentioned AH, BH, maybe I'll mention that later. But if I want to see now the point views of these two lines, because both of these guys are in true lengths on this plane. So if I look at these two lines from here, I need to make a hinge line which is perpendicular to either one of these. Okay, get the projections. From where am I going to be getting the distances? From there, because now this view is common between this guy and the view that I'm going to be making. Okay, so I'll get that distance transferred over there. I'll get that distance transferred over here. Ha. So far so good. Now what? Okay. Yeah. So my mistake. But so nice, right? You guys realize that. So this guy should be here, right? Okay, so this distance should actually have been here, and that distance should actually have been here. Okay, so just flip these guys over, and essentially you're going to be getting this point view over here, this point view over here. So point view of point view of AB will be here, point view of CD will be there. Yeah? Okay. Next, perpendicular to a line from a point. You got the projections CD in the horizontal plane and vertical plane, and you also got the projection AV and AH in both planes. Okay, I'm doing a Dhoni here, so I'm trying to make runs fast. Okay, hinge line. It would be a good idea for you to sketch alongside this lecture. Okay, give you a nice practice, and hopefully you will be. So two things will happen. Number one, your eyes will not get heavy. Number two, it'll be nice. I mean, you'll get some practice. Okay, so I'll start with the hinge line. So remember, whatever exercise I'm doing with respect to this view, I can do exactly the same thing starting from here. Nothing stops me. Okay? So I'll draw a new hinge line parallel to CHDH. Here. Take the projections, get this distance transferred over there, get that distance transferred over there. I get C1 D1 in true length. Wonderful. And then I'll do the same thing for A. I'll take projection which is perpendicular to this hinge line. I'll measure this distance transferred over there, and I'll get my A1 there. Okay? Okay? All right. So the question is to figure out a perpendicular, okay, from point A in 3D onto C1 D1 or CD, the three-dimensional line CD. This is what the question is. All right. So at this time, maybe I'll just move forward. I'll try to get the point view of C1 D1. Draw a hinge line perpendicular to this projection. Okay, I hope I'm not making that mistake again. Get that distance, measure it over there. This is my point view of CD. Okay, and then likewise, I'll measure that distance. Okay, draw a projector perpendicular to that hinge line from A and transfer it over there. This is my A2. So this is my first auxiliary plane that contains the true length of CD. This is my second auxiliary plane that contains the point view of CD. Yeah? Okay. Now, is it okay for me to draw a perpendicular from A1 to C1 D1 and say that this would be perpendicular? Why not? Why not? Why not or why? Both questions. This would not be the actual length, but this would be perpendicular. Okay, do you agree? The plane in which this line is in true length, okay, I draw a perpendicular, this will remain perpendicular. Okay, but this guy may not be in true length. Okay, so on this auxiliary plane, it's only the projection of this line that you see. To get the true length, I'll probably have to go over there. Would this be in true length? Why is that? Because this guy is parallel to this hinge line. If one of the projections is parallel to the hinge line, the other projection will contain the true length. Quite mechanical now. Yeah? So this would be in true length. So you'll have the perpendicular over here. You'll ensure that this guy is perpendicular, and you'll find the true length of this perpendicular from here. Get back. You figure this point of intersection. Let us call this B1. Go back. Okay. Of course, B1 has to lie on CD. So you get BH, come down, Okay, of course, B has to lie on CD, so you get BB. So this is your first or projection of your perpendicular in the horizontal plane, and this is the projection of the same perpendicular in the vertical plane. With me? Now better to understand? A lot easier to understand compared to previous lectures? Last part? From where? From where? Till this is fine? Till this is fine? That would be in true length. This is point B1. Okay, B1 has to lie on C1 D1, right? Come up, and these projections, they are going to be parallel to each other. Okay, so the corresponding projection of B in the horizontal plane is going to be BH on CHDH. Come down, the corresponding projection will be BB. Okay, and you join just AHBH over there and ABBB over here. No rocket science. How's your galaxy going? Starting? Okay. Anyhow, so this is clear? Is this clear? Okay. Shortest distances between lines. It's going to be a long day today, so bear with me. But I really want you to understand this, because if you don't, then you'll have difficulties starting Monday. Okay, so it was important for us to have this class. One look at this figure and you will realize that the points or the lines are intersecting or not? They are not intersecting. The reason why? Because you don't see the corresponding projection of the intersection in the horizontal plane over here. Okay, so they cannot be intersecting. Okay, they are skewed in space somewhere, right? All right, same thing. Same thing, a hinge line, try to get the first auxiliary plane, projectors perpendicular to that hinge line, okay, from everything A, B, C, and D. Okay, things might be a little messy, so I want you guys to follow this carefully. Measure this distance, transfer it over there, measure that distance, transfer it on the projection from where on the projection emanating from DH over there. So this is your C1 D1. Okay, and since this projection is parallel to this hinge line, this would be in true length. Okay, do the same thing for the A's and B's. Take that distance, transfer it over here on the projection starting from AH. Take that distance, transfer it over there. Okay, and you would be getting A1, B1. Okay. This guy is in true length. How about this guy? Not in true length. Fine. Now let me try to visualize these two lines from a plane from where I can see CD as a point. Okay. Get the point view of CD. Make a line or make a hinge perpendicular to CD. Okay. Draw this projector, measure that distance, transfer it over there, and this would give you the point view of CD. Okay. Draw two other projectors from A1, B1, perpendicular to this guy, this hinge line. Where are you going to be measuring the distances from? Here. Okay. Measure that distance, transfer it over here. If you have not noticed, let me emphasize that these distances are to be measured. They are to be measured from the hinge lines. Okay, it's critical. Okay, not to be measured from the points, but from the hinge lines every time. Okay. All right, so measure that distance, this little one from this hinge line, transfer over there, and this is your A2, B2. So on the second auxiliary plane, you see CD as a point, and you see the projection of AB. Okay, would A2 B2 be in true length? Good, not a problem. How do we find the shortest distance between lines? I draw perpendicular. Okay, right there I draw perpendicular. Okay, all right. Is this going to be in true length? Why do you say yes? It's perpendicular to CD also. But you don't know, do you? As of now? Yeah, but would this plane or would this projection of the perpendicular give you the true length? Fine. So you say yes. Okay, you say yes, but I'll retrace my steps back and convince you that it is actually going to be in true length. For those who believe, great, but for those who do not believe that this is going to be in true length, I'll convince you that this is going to be in true length. Okay? At this time, I just pose a question, whether this is going to be in true length or not. Anyhow, so I track back. Okay, I call this point M2. I go back. M2 is going to be lying definitely on A2, B2. Okay, so M will be part of AB in general, everywhere, on every plane. So this would be M1. Okay. If that is the shortest distance, it has to be perpendicular somewhere, right? Okay. All right. Now, since this guy is parallel to the hinge line, okay, why? Because this thing is perpendicular to CD. Shortest distance has to be perpendicular to both lines, right? Okay. Now you can just see that it is perpendicular to C1 D1, but you can verify later whether it's perpendicular to AB or not in some auxiliary plane. Anyhow, so once you verify that this is parallel to this, that would be in true length. Yeah? So all you need to do is name this intersection point as N1. Okay? Get both M and N back. M lies on AB, N lies on CD. Okay? On every plane. So this is MH, NH, MH, NH, and here this point would be what? MV, NV. Wait, let me complete this. Let me complete this. Till here. Yeah. So till here. So ignore this part of the red line. So it's going to be till here. Yeah.
So while justifying that we got the perpendicular and true length in the second auxiliary plane, so you assume that the point N1 lies on CD such that M1 N1 is perpendicular to C1 D1.
Yeah.
So why is that so? Why did we take N1 such that it is perpendicular to C1 D1?
The shortest distance is going to be perpendicular to both lines.
Yeah, but how?
Do you agree? The shortest distance is going to be perpendicular to both lines. Now, if you're seeing one of the lines in its true length, that shortest distance will be perpendicular to it. That's all. Yeah?
By drawing for the first time when you draw the perpendicular line, then why did you draw it perpendicular to A to B? I mean, a line which is A to B is not just true length, right? In the previous view, A to B to A1 B1 is not perpendicular.
If I draw this line, so you're asking as to why did I draw this perpendicular to A to B2? Okay, I could have drawn it like this, but would that have been the shortest distance? I could have drawn that like this, but would that have been the shortest distance? This would be the shortest distance, and that's the only possibility.
You mean to say that if there is a line which is the shortest distance, if we take its projection along any plane, it will remain the shortest?
It has to. In reality, in 3 dimensions, if I have this line and if I have this line, if I am going to be computing the shortest distance between these two guys, that line would be unique. That would not be changing. It's just that their projections will be different in different planes.
Suppose that I have two lines.
Step up. Do we have another pointer? Okay, turn around. This is one of the lines in 3D. This would be the other line in 3D. Figure out the shortest distance.
Perpendicular to both.
Perpendicular to the board. Yeah. Show that. Yeah. Now, what's your question?
Sir, I am asking that suppose we have two lines. Okay.
Yeah.
One is the shortest one.
Yeah.
One is somewhat lengthier than that.
Yeah.
If I take the projection of both the lines along any plane, is it always true that the projection of the shortest line will always be shorter than the projection of the longer line? I mean, in true length, definitely there is.
Not necessary. Not necessary.
Then how can we?
What? Have a seat. Have a seat. But listen. So this auxiliary plane is slightly different. In this auxiliary plane, you are seeing one line like this, okay, in the point view, and the other line or the projection of the other line somewhere. Okay. How would you see the shortest distance? Absolutely, which is what this is. Yeah? So that plane is slightly different. But if you want to do this exercise, try to get AB in its true length and figure out what this projection is going to be. Okay? Alternatively, yeah, but just a moment before I. Alternatively, I started by finding the point view of CD. Okay, do the same exercise. Instead of making this hinge line, make a hinge line that's parallel to HBH. Get the point view of HBH, draw that shortest distance, and see really if the true lengths of the corresponding shortest distances are the same. You could do that, and you could verify. Yes.
So if we talk about C1 D1 and A1 B1,
Yeah.
so from point M1 to drop a perpendicular to C1 D1.
Okay. Can you be a little silent, because otherwise it becomes a little difficult for me to hear. And can you be a little louder?
So in C1 D1 and A1 B1,
And slow down. So C1 D1 and A1 B1. Yes.
drop the perpendicular from M1 to that point L1.
Yeah. Yeah.
So here you are saying that because like C1 D1 is in true length,
Hmm.
the shortest distance should be perpendicular to C1 D1. The line connecting the two lines,
Yeah.
the shortest distance line,
Yeah.
perpendicular to the true length line C1 D1.
Okay.
But in that the second auxiliary plane,
Yeah.
that PL value, that shortest distance is definitely perpendicular to the point view of CD.
Yeah.
But how do you now say that it should also be perpendicular to A to B? Because that is not in true length.
This is what I'm saying. Let me try to understand what you are asking. So you're saying step 1, I drew a perpendicular from here to here. Okay. Step 2, I drew a perpendicular from here to here. Now let me counter ask a few questions. Okay. Are you convinced with this step? Not very much.
If, why is it that that length is true length? I don't get it.
It is true length because the shortest distance has to be perpendicular to both lines. Okay? Agreed? If I am seeing one of the lines in its true length, that means that I have been able to capture that line on that corresponding auxiliary plane. the shortest distance will be perpendicular to it. Agreed? Do you agree with this then? If you agree with this then, okay, then this guy is parallel to this hinge line, okay, because both of these are perpendicular to C1 D1, right? Okay. Now, if I go from here to here, the projection of any line segment which is parallel to one of the hinge lines, okay, the corresponding projection in the other view has to be in true length. It has to be, right?
Let's say if we go the other way around, like if we start from point P of CD, you draw the perpendicular from point P of CD to A to A.
Do you agree with that?
Yes, so that thing I understood.
So, if you agree with this and if you agree with this, then your question is,
Why point P of CD and M2 line is perpendicular to A to A. Like we can start from M1,
this is the point view of CD. This is my line here. It could be anywhere. Okay? What is the shortest distance that you're going to be dropping from the point view of CD onto this? Got it? All right. Okay, coming forward, rather going forward. Enough of lines, now into planes. Given the projection of a plane, given the projection of a plane in the horizontal plane up there, and the projection of the corresponding plane, the vertical plane. Okay, so these guys are the projections of plane of a plane. Okay, AV, BV, CV down there, AH, BH, CH up there. Look at the corresponding vertical projections, they have to correlate. So A with A with A, B with B, and C with C. Okay? The question is to find the edge view of the plane, number one, and to find the true shape of the plane if I can. Okay? Can I have one of your, yeah. So imagine that this guy is what you see over here on a triangle. Okay? And imagine that this guy is what you see over there. Okay? Now the edge view, so this is the true plane, for example. The edge view of the plane will be like this for you. Okay? The edge view of this plane will be like this. And if you flip this plane over, or rather if you rotate that plane about this edge view, you'll be essentially getting the true shape. Right? Now the question is how to find the edge view of this plane. Okay? And then I know that if I flip this plane over by 90 degrees about that hinge, I'll be getting the true shape. Fine? Now, it might seem a little difficult, but it's not very difficult as it seems. Okay? Now, be very careful, be very attentive, and follow the following steps. I start with a hinge line. Now, what I do is something smart. I locate a point DH. On BHCH in such a way that AHDH is parallel to the hinge line. Okay? That's the smarter thing that I have done. The second thing, well, not very difficult. I project DH down and get that corresponding point here on BBCV. Okay. Now this guy, if you just treat this guy as a line segment, it's parallel to the hinge line. Okay. Here, this would be in true length. Okay. Okay. And if I look at this plane, okay, in such a manner, or rather, let me go back. Next step I would do is I would draw a hinge line perpendicular to this line, AV DV. Okay. So in the process, what I'm trying to do, I'm trying to find the point view of AV DV. Okay. Project this line and measure distances. Okay. So that distance will be transferred over here. This distance gets transferred over there. This distance, okay, from this hinge line to CH gets transferred over there, and this distance gets transferred over there. Okay. Fine. This is what I've done. Something very simple, something very mechanical. Okay. And then this is my first auxiliary plane. I join these three guys, these 3 points, horizontal plane, vertical plane. That's the vertical plane, and that is the first auxiliary plane, A1. Okay. DV comes now, strangely. This is the point view of AVDV, and this is my CA1. Okay. This is my BA1, and here I would have DA1 and AA1. Okay. Once again, this is my CA1, this is my BA1, and here I would have DA1 and AA1. Strangely, I've got all the 4 points on a plane onto a single line. Yeah? Yeah? I've done nothing special. All I've done is I have found a length, I found an edge on the plane or a line segment on the plane true length. Okay? And I've just viewed that corresponding projection of the plane perpendicular to this. That's all I've done, nothing else. So strangely, this entire plane is now represented in this auxiliary plane by this line segment. Is this the edge view of the plane? This is what we wanted. This is what we wanted, didn't we? I could do the same thing starting from the vertical plane. Okay, let me go over this real quick. Parallel line, project DV to DH. This would be in true length. Make a hinge line perpendicular to AH DH. Okay, shoot the projectors out from these vertices. Okay, measure this distance, transfer it over there. Measure this distance, transfer it along CH. Measure this one, transfer it along BH. Draw this line segment. Okay, this is the edge view of the plane. Okay, that is the horizontal plane, that's the auxiliary plane 1. And again, you see that all these vertices lie on the line segment. Okay? Okay? All right. Now, if I draw a hinge line parallel to this edge view of the plane, okay, and try to see how this guy looks perpendicular to this edge view. Okay, same thing. Shoot the projectors, measure distances from where now? From where? From here? Okay. This is between A1 and A2 hinge line. measure that distance, transfer it over there, measure this distance, transfer it over here somewhere. Now this distance is from here to AH. Okay, measure this distance, transfer it over here. This is the true shape of the plane that you'll be getting. The beauty of this construction is nowhere am I using coordinate geometry. Nowhere I'm using mathematics. Simple lines. That's the beauty of it. Okay? All right? Can I go back to the previous example and get the true shape of the thing? Nah. Yeah. Real quick. Real quick. Okay? And can I try to compare these two shapes? No? Hey, half an hour more. I have to finish this lecture. Just 2 minutes. Okay, so I get this true shape from the previous example. Okay, I merge that true shape in such a way that one of the vertices coincide, then one of the edges coincide, and then I flip it. So both will expectedly give you the same shape. Now, I have to finish this lecture, number one. But I will give you the freedom to, go back and do whatever you want. So here are two proposals. Proposal one, we take a break for 5 minutes. You can wash your face, drink water, and then decide whether you want to come back or go to your hostel room. But I will have to stay here. I will have to finish even if none of you are here. Okay, I think we are almost done. Let me see how much. I have. Line parallel to a plane. Is it straightforward? Get the plane in the edge view. Get the plane in the edge view. Draw a line parallel to it. I'll quickly go through that. Quickly go through that. See, listen, otherwise, see, if I don't finish this, then you guys are going to be having a problem in the next week. I won't. You guys will be facing problems. Okay? Bear with me for 5 or 10 more minutes and then you guys are free. All right. Horizontal line, AHDH. Stay with me, guys. You guys are what? I mean, you guys are so young. Huh? You guys are so young, I mean, full of energy. Come on. I so much wish that many of you guys come back and start teaching. Okay? Teach as I teach. Then you realize, I mean, what teaching is. If not all, at least 10% of you guys. All right, so this is DV. This is going to be in true length. Draw a hinged line perpendicular to AVDV. Shoot the projections. Okay, measure distances. Transfer distances. Straightforward. This is not very difficult. This is the edge view of the plane. Okay, edge view of the plane. Get the points. Not a problem. Do the same thing for point PH. Shoot a projector perpendicular to this hinged line. Measure that distance, transfer it over there. This is what PA1 is. Draw a line parallel to the edge view of the plane. Okay. Any given length, let that point be QA1, trace it back. So if you assume that is going to be in true length, which is actually what is going to be true, okay, then this guy has to be parallel to that hinged line. Okay, get this point, QV, measure that distance, shoot that projector, Okay, transfer distance, get QH, this is what your line is. Okay, so if you just look at this picture and this picture, it is not at all clear if this line is parallel to the plane. Is it? Is it? Strange, no? But only this view gives a clear picture. Yeah? How did? If this is in true length, this has to be parallel to the hinge line. Basic golden rule. Yeah? PQ should not change in TS view of ABC. Let's see what this is. All right, so if I make the true shape of the plane, okay, and what am I doing here? Measuring the distance, transferring over there, measuring the distance, transferring over there. All right. So what am I saying? So this length would remain the same, is it? Over here and over here, and the only way this is going to be possible is if both these guys are parallel to the hinge line, is it? All right, fine. So, all right. So now same thing. Line perpendicular to a plane from a point. Stay with me. Stay with me. Just about getting done. Hinge line. AHDH parallel to the hinge line. Okay, I get true length. I make the edge view of the plane, shoot the projectors, get distances, transfer distances. Okay, get the edge view of the plane. Stay with me. Mark these points. Okay, I do the same thing with the point. Measure that distance, transfer it over there. I get that point as PA1. And if I want to draw a line perpendicular to a plane from a point, this guy has to be perpendicular. This point has to lie on the plane, QA1. This should be in true length. Should this be in true length? Haha, you guys want to go back. This, okay. If this is in true length, then this would be parallel to the hinge line, and make sure or know this very well that Q, the corresponding projection of Q over here has to be lying on this plane. Okay, so this is QV, and measure that distance, project QV up there, transfer the distance. This guy has to be lying within the plane. This is QH, and this is the line which is perpendicular to the plane in both horizontal and vertical planes. Okay, all right. Forget about that. Verification PQ should be in point view. Wait. This is important. PQ should be in point view in the true shape of ABC. Would that be the case? All right. So if you get the true shape of the plane, okay, and if you get the corresponding projection of PQ onto the true shape, this would be the point. It should be in the point view. You know, so when you're doing this, always verify, always have those little thingies that you can use to verify whether you have done something correct or not.